simplex method, we have seen that there will be like a two ways
Sir?
of solving the. Yes, please. Can you hear me, please?
Nothing, sir. I thought to tell to record the video.
Okay. So thank you. So as you know, in a simplex method, we have seen that in this simplex method, we can be able to use two methods, okay? Two methods in order to solve the given problem. The problem can be given in one way or another. So when we want to solve the problem, we can utilize two ways. Number one, you can use a simplex method, okay? When the equality, when the signs is like this way, this is what we have seen. Let me use this one. When we have lesser than sign, then by this way, we can use only the so-called, we can use something which is called the slack variable. Okay, we can use the slack variable. The slack variables, okay? So when the sign is greater than or equal to, then by this time we use a surplus. We use surplus variable, okay, plus artificial variable. Okay, so when the sign is equal to, when we have like this sign, both these are the signs. When we have the equal sign, here also we use something called, we apply something called the artificial variable. The artificial variable, okay, to balance, to do what? All this one, we include this one in order to convert in equation into equation, or to balance our equations. Okay, so when we use this surplus and the artificial variables, okay, this concept is known as technique of using artificial variable. Okay, the technique of simplest method using artificial variable. Okay, so to the question which we have seen yesterday, look at this presentation, look at this PPT which is here, which is given below.
Sir, we can't able to see the board.
You cannot be, okay, now you can see the presentation now. I will share the board. Okay, fine, wait. Okay, wait, I just want to make sure that the board is visible. How about now? Now you can see, right? I hope now you can see the board. Is it clear? Is it visible, the board? Is the board visible? Yes? Okay, good. So this is what I was saying. That this is what the point which you have to mark. And to make this point to emphasize before we look to the artificial variables, remember all Cj minus Zj should be, when they are lesser than 0, then by this time we mean that we have the objective function is maximized. Okay, is maximize Z. Okay, this is a point to note. When all Cj minus Zj is greater than or equal to 0, this one, then by this case we have the minimize Z. Okay, minimize Z. So when we have this one, now when all these things has been attained, here you say that you got the so-called the basic feasible solution. Okay, or you got something called the feasible optimum, so you got something called the optimum feasible solution, the optimal feasible solution. Clear? So now this is one point. Another point I told you yesterday, when you have applied the Cj minus Zj, which is lesser than this one to maximum, if you have converted the minimize, for example, you convert the minimize by, let's take an example, this was a mini Z, minus, okay, z, which is equal to x1 plus x2. Okay, if you convert this one to maximize, then we'll have like this one, star minus x1 minus x2. So by this case, you will do the inverse. You will do the inverse. Or Cj, here you will do this, you will do Zj minus Cj should be greater than 0. Okay, for the minimized case, should be greater than 0. All right, when you convert this one. When you convert this for minimize, okay, or when you do this one, when you convert this one, you have to say Zj minus Cj should be equal to 0. When you balance by minus, okay, should be lesser than or greater than 0. Okay, you should convert this one. It should be greater than, sorry, this should be greater, sorry, this should be greater than, this should be lesser than, should be lesser than. Okay, should be lesser than. Correct. So now let me show you here. Let me share what I was telling you here for the artificial variables. So this is the point which we have discussed, which we are looking from yesterday. Now let me come to the exact exercise which we have done. So this is for the case of maximization by using what? By using the slack variable. No, by using, yes, surplus variable, and by using something called the artificial variable. As you can see to the constraint given there, all right, as you can see to this constraint given here, what is that? The constraint which is given here, look at this constraint, look at this constraint which we have here. Look at the first constraint. How is it? How is the first constraint? The first constraint, the sign is greater than. And the objective function is maximize. Okay, the objective function is maximize, which means to say that Cj minus Zj should be lesser or equal to 0. Okay, it can be minus or it can be 0. It can be negative, it can be negative, or it can be 0. So when we have lesser than, here we are going to introduce a slack variable. When it is greater, look to this one. When it is greater than, we are going to include we are going to subtract this one is known as surplus plus artificial variable. Okay, artificial variable. That's what we're going to do here. So for the first constraint to convert it, now we have converted into a surplus, a slack variable. Second, we have converted into surplus, and the maximize, we have to do what? We have to add the 0 coefficient slack 1, 0 coefficient slack 2 till slack n. Okay, it's nothing ending here. This is the starting process. Okay, so when we introduce the surplus variable, okay, it has to go along with the artificial variable. Look to this equation which is here. We have included plus a1 because we have only one constraint which is greater than. Okay, a1 means a stands for artificial variable. All right, so and in the maximization we have to minus m. M stands for penalty, maximum penalty for this one. Okay, so these are the steps I told you yesterday. Let us look to the exercise which we have seen yesterday. Okay, so this conversion, all this we have seen yesterday. So this is an important point to understand. The initial visible solution is S is equal to 1, A1 is equal to 2. These are the basic. So X1 and X2, they're non-basic. They are equal to 0, even S, okay? Even S, all right? So in case there is any artificial A, we consider that artificial A rather than considering the second variable in coefficient, okay? In the basic coefficient, okay? So look at the table, how the table is being formulated. All right, so as you can see the first CBJ here. What is CBJ? CBJ stands for coefficient of basic variable. And I try to mention R1 in order to tell you this is row 1. Okay, this is entire row. This is entire row. All right. So you can see, sorry. So you can see this entire row. Okay. These are the entire row. This is the row. This is row 1. This is the low one. This is the entire row. All right. This is the entire row. So in this first column, as you can see, this is for the coefficient of basic variable. Okay. This is the coefficient of objective function. Look our objective function here. It was a 3x1 and a 2x1. So when we convert this one, when we convert the constraint into equation, what happened? We had 3x1, 2x2, 0s1, 0s2, and minus ma. Okay, minus ma1 because it was a maximum. If it was a minimum, we would have had plus m. Okay, plus m. All right. So in a basic variable, we have s1 and we had also a1. As I told you, in the presence of artificial variables, we consider it as a coefficient or a basic variable rather than the slack variable or surplus variable. Clear? Look to the second equation here, to this second equation. Since it has been converted, what do we do in a basic variable here column? We have to consider the artificial variable. All right, the artificial variable. So here, what did we have? The first row. This first row. The first row, we made it as this one. For x1, we have a 2, 3, 2. The coefficient is a 2. And the coefficient, this is x1, sorry, right here. This is x1. And for the x2, we have 1. For s1, as we have introduced like this way, look this way. We have introduced 2x1 plus x2 plus s1 plus 0s2, okay, is equal to 2. This is the first one. That's what we had. Okay, we had the 0, 1, 1, 0, 0, even plus 0a1, plus 0a1. All right, plus 0a1. And the value is 2. This is the value. This is the value here. Clear? Now we come to the second row. The second row. All right, the second row, x1 is equal to 3, 3x1 plus 4x2, 4x2 plus, is it plus? We are going to minus. We are going to minus because it is converted from, it is converted from inequality to equality by subtracting the, what? The surplus. This is a surplus minus s2 plus a1. This is equal to 12. All right, that's what we have. 3, 4, 0, s1 minus s2 for surplus, and plus 1 for what? For artificial, and the value is equal to 12. Clear? Now this one is going to, we are going to calculate zj. How do we find zj? Zj is equal to, what is zj? Zj, we are going to take zj, sorry. We are going to take zj. Zj is equal to cbj, okay, cbj into aij. So for the first column, we are going to go for the column wise. This first column here, we are going to take cbj 0 into 2, all right, plus minus m into 3. So that's what we get, minus 3. Okay, minus 3. For the second column, we do the same. 0 into 1, 0 into 1 is equal to 0. Minus m into 4 minus 4. Here same, here 12, because we had 0 into 2, and minus m into 12, we have minus 12. Clear? Now, once we find Zj, what we're going to do, we are going to calculate, what we're going to calculate, we are going to calculate Cj minus Zj. Cj minus Zj. Cj value is a 3. 3 minus, we are going to take 3 minus 3m is equal to what? 3 plus m. 3 plus 3m. Okay? 2 minus, okay, minus 4m. What is the value? 2 plus 4m. And so on. This one and this one. This one and this one. This one and this one. Okay? This one and this one. Is it clear? Is it correct?
Excuse me, sir.
I think it is. Sorry.
Excuse
yes,
me,
please.
sir.
Yes, please.
Sir, in the basis, why S2 is not been taken, sir?
Yes, in this one, in basis. Okay, in basis. In basis, instead of taking S1, we take artificial variables because S1, okay, because S1 and S2, they can be considered as the same. They can be considered as an additional extra variables. So since you are dealing with artificial variables, the artificial variables, it's going to be the maximum penalty rather than becoming the surplus or a slack variable. That's why in the basis, it is absent. That's why we don't use them. Okay, that's why we don't use S2 in a basis. All right, and again here, since look here, we have how many? We have only 2 equations. We have only 2 equations. So you cannot introduce the third basic variable here when you have only 2. It will be the repetition of the same line. So we consider to use the artificial variables. And the purpose of these artificial variables is to eliminate them here. At the end, we want to eliminate these artificial variables here, okay, from the basis, even from CBJ. We want to find the last answer where it is eliminated, okay? So, I think here there is a wrong calculation. Have you seen? Is it correct? Is it correct here? I think here it's wrong calculation. Check this one. What is the value for this one? I think here there's a mistake. Have you noticed the mistake there? Look at this. Look at this one. Okay. Let's look to this one, to the first one here. Here we had minus m, correct? Minus m. Here we had 0 into 0 is a 0. Minus m into 1 is minus m for z. Okay, for z. Now, for the value of this one was minus m, minus m. Clear? Because z was m. So the value has to be 0 here. Is it clear? The value has to be 0, not m. Because it's a minus m plus m is equal to 0. Clear? Is equal to 0. Please note that one. So this is the value. Now, the important point here. Now, which CJ to choose? When it is maximization, when we have the case of maximization like this one, you know, the column to be chosen as a key column, it is the CJ minus ZJ, which has the highest M, value of M. Look here. Here we have 3 plus 3M, correct? The second column, we have 2 plus 4M. And the third, we have a 0. And the fourth, we have minus M. So the column to be chosen, it is the one which has the highest M, which is this one, this second column. Clear? Remember, in a simplex method, we would have chosen only 3, right? Because 3 is the highest. But in artificial, since we have used the artificial variables, we choose the one which has the highest penalty. This is M, highest penalty. So in a case of minimization, maybe if time permits, we shall see in the case of minimization. Let me see if the next slide is there. Okay, I think, yeah, in this case here, we shall look to this case, okay? Yeah, it is there, it is included. All right, so we are going to choose the column or we are going to choose the value which has the highest M or highest penalty. What is that one? It is a 2 plus 4M. If they were 1 plus 7M, so we do have chosen this as a column. Okay, so this one is going to be treated as what? This one is going to be treated. This one is going to be treated. This one is going to be treated as a key column. And once we treat this as a key column, the whole of this one is going to be selected. Okay, the whole of this, all of this one is going to be selected. Which one? This is going to be selected as what? As a key column. Then how do you find the ratio? The ratio is being found by taking, sorry, these two, only these two. How do you find the ratio? The ratio is going to be taken by value divide value. We are going to take a 2, divide the corresponding one, this one. We are going to take 12 divide 4. Now we look at the smallest or the least value ratio. It is 2. So when it is 2, then this law is going to be the kilo. It's going to be the kilo. All right. So now to calculate the low one, to calculate the new the new low row 1 and the new row 2, how do we calculate them? Simple, same as the way we did. Okay, it will be applied as a same since it is maximization. If you remember, for calculation of maximization, it will be applied as a same. How did we find that one? How did we find that one? How did we calculate the how did we calculate this one for maximization? Okay, how did we do that one? Look at this one. Let me stop the shared screen so you can be able to see the board. All right, so I'm going to write a simple one here. Simple note here. I hope the board is visible. All right, for calculating the new law, look here. We're now going to calculate R2. Sorry, this is supposed to be R3. It's supposed to be R3. It should be R3. And this should be R4. Okay, to calculate R3, how do we calculate R3 when it is maximization? We take, what do we take? We take the odd element. We are going to take the odd element of R1, correct? Of R1, that's, let me take like R1 minus, what is that one? Minus, what are you going to take? Corresponding, minus corresponding, minus corresponding key column element, into what? Corresponding kilo, divide what? Divide the key element, okay, divide the key element. So we do the same. Let's try to see for, let's try to see for the first one. Let's see for the x1. Let's see for the x1. All right, let's see for the x1 how this one, as you can see, x2 is going to be the entry. X2 is going to be the entry in this presentation, in our table. Hold on. X2 is going to be the entry. Okay, the x2 is going to be the entry row. X2 is going to be the entry row here. X2 is going to be the entry row, and S1 is going to be the exit row. It's going to be the exit row. Clear? It's going to be the exit row. So for x1, how did we find the x1? How did we find 2? Let's see how the 2 has been found. All right. For the new row, for the new entry, this is for calculating. This was like R3. Yeah, R3. If you want to calculate the new entered law, same as what we have seen. The only difference is to find the key column by using highest penalty. This one will be equal to the odd element, okay, divide key what? Divide the key element. So for x1, look like x1, how x1 was. Look here, look at this one. It was 2. Okay, it was 2, right? It was 2. We took 2 divide 1 is equal to 2. Clear? And second one, we took 1 divide 1 is equal to 1. 1 divide 1 is equal to 1. Okay, 0 divide 1 is equal to 1. 0, sorry, 0. Same, okay? Then you can calculate for the A1. You can calculate for A1. You can calculate the law for A1. How the A1 for A1? Okay, you can calculate the value for A1. What is the value of X1? Okay, it's like this one. A1, and you calculate the value for X1. How was it? How has been calculated by that one? The odd element was a 3, let's see, was a 3 minus what? The corresponding key column was 4. Into what? Corresponding kilo was a 2. Okay, corresponding kilo was 2. And what is the value? Is a 3 minus 8, which is equal to minus 5. Okay, which is equal to minus 5. Same. So you apply the same. As you can see here. Okay, as you can see here. Look here. The value for the x2. All right. The value for x2, this one. All right. This is the odd value. The odd value was a 3. Sorry. The odd value was 3. And we have selected this as this one as a key column. The corresponding key column element is 3. The corresponding, this was a kilo. This was entire was a kilo. The corresponding kilo was a 2. So we are going to take 3 minus 2 into 4 divide 1, because 1 is what? 1 is a key element. So which is equal to 3 minus 8 is equal to what? Is equal to minus 5. So you do this one, you do for the second, you do for this one, same. Once you do that, you find Zj. So in Zj, when you want to find the final value, in the final value, you consider the independent variables. Like when you have like m, okay, m plus 1, okay, 2m plus 1, and you have like a 3m, and you have a 3m plus 0, let's say like this one, and you have like minus 1 plus 5m. Okay, in this case, you consider this independent value. In this case, all right, since all independent value are what? Are minus and 0 minus 0, okay, this one is going to be considered, this is going to be 0. The value of this one is going to be 0. So this is going to be considered as the final stage, because the Cj minus Zj is lesser or equal to 0. Minus 1, 0, minus 2, 0. Okay, this artificial variable is not going to play a part in what? In finding the final answer. It helps to find the key column. Okay, the key column. So here it says, since all Cj minus Zj is lesser than 0, the artificial variable A1 appears as what? As a basic at no 0 level. The given PP does not possess any feasible solution, but it possesses something called the pseudo-optimum solution. Okay, it contains pseudo-optimum solution. So, for the next exercise, I believe this next exercise, you shall see the exact answer. So take a note of it for this exercise. So for this exercise, you will do it. I will give you time to do. Let me check if I have sufficient time. Yeah, I have sufficient time. Let me give you 10 minutes to solve for the first exercise, okay? 10 minutes, because I still remain with another 20 minutes ahead. So take a note of it and solve it. Just to remind you, I hope you have written. I hope you have written, you have taken a screenshot of it. Let me stop this one and see if you can see the camera. Just to help you. Are you able to see the board? Is the board visible? Surya, you can see the board? Surya? Ashish, you can see the board? Pretty? Kevin? Is the board visible to you all?
Yes, sir.
Yes?
Sir.
Okay, good. Okay, good. So you're going to solve this as a minimization. Keep in mind, in minimization, CJ minus ZJ, okay, should be greater than or equal to 0. Okay, keep in mind. And what you will do, you will check for what? For artificial variables, EM, for these penalties, for EM, you will check for the EM. If in the case of minimization, the artificial variable here will be plus M, not minus M in Z. Okay, in Z we have a plus M, let's say M1. Okay, M1. Clear? So please at least make the initial variable so that I can see. Look like this first. Let me show you for this one. For this one, it's I'm going to show you to convert it. Okay, we are going to convert this one. It's going to be converted. That one. We are going to convert x1 plus x2 is equal to 5. Okay, and convert this one x1 3x1 plus minus 4x2. This one, please look like this one. Look this one. I'm going to show you this and then you convert it. Okay, we are going to have x1 plus x2 is equal to 5, and this is subject to constraint. Okay, here we have a minimize, mini z. In a mini z we have x1 plus x2. Okay, let it be like that, no problem. And here we have, here let me put 3, x1 plus 3 x2, and here we have like x1 plus x2, okay, is lesser than or equal to 3x1 plus is lesser than 4. And here we have minus x1 plus x2 is lesser or equal to minus 7. And here we have 2x1 plus 6x2, okay, they're greater than 12. Anybody can convert this one fast? Please convert this fast. Please convert the whole problem. Please convert this the whole problem, okay? Convert it. Let me try to balance, okay? Let me try to balance. Look here. Let me put here minus 2, okay? Let me put here 6, all right? 6, okay? Let me put here 4, correct? Yeah, please convert this one, convert the given, solve this one using, the question is solve, okay, LPP by what? By which one? By using big M method. Okay, solve this one. Please convert it and show me this one. First convert it, convert this one, and formulate the table as well. Formulate the table. All right. By formulating the table, please keep in mind what you have to include there. Please, first I want to see if you can do this one. I just want to check your answers within a few minutes. Okay, please do it. Do the first convert it, and then for those who finish, for